Today we're going to talk about medians and altitudes, okay? And the first one we're going to talk about is a median. Whoops. That goes in this first blank right here, median. Where do you see the median at? In the middle of the road, right? So guess where the median is going to hit? In the middle, okay? So a segment, the definition of a median is a segment joining a vertex, so that means one angle of my triangle, to the midpoint of the opposite side. Whoops. Sorry, my pen's not wanting to write properly. Okay. A median in my triangle would go from the vertex to the midpoint of the opposite side. So you would have those markings to show you that it is a median. Okay, just like that picture right below the definition. Everybody okay so far? All right. And then the centroid is the next definition. Centroid is how you say that. And that is the three medians of a triangle intersect in a point called the centroid. Everybody good? Okay. So what I want you to do is, the first thing is we're just looking at that picture over there, and it wants me to list the medians. Again, those are segments that go from a vertex to the midpoint of the opposite side. So I want you to start with that first vertex, the one at the top. What point is that up there at the top? B, okay. What is this name of the segment that goes all the way and touches the midpoint of the other side? B what? BF, okay, that's my first median. So that's what I want to fill in that blank. Okay. Again, it goes from the vertex to the midpoint of the opposite side. So that is BF, and it is a segment. We have two more medians in that picture. You want to take a guess? Yes, DC or CD, however you want to call that one. Goes from a vertex to the midpoint of the opposite side. And what was the third one you said? AE. It goes from that vertex to the opposite side. Okay, so my three medians in this picture are BF, CD, and AE. Again, the order of the letters doesn't matter as long as you have those two. The centroid is the point where they intersect in that picture. What point do those three medians intersect at? P. Okay, so guess what my centroid is? Point P. Okay. Now this next one is who? Mm-hmm. There are several different properties that exist with a centroid, okay? I'm going to specifically just use one centroid, but this is true for every centroid. Okay, so I'm going to focus on the one that's going straight up and down. Okay. So what I want you to look at, the first one is that, do you guys see segment PF in your picture? Do you see PF? It goes from my centroid, from my centroid to the bottom or to the side of my triangle. That is going to be 1/3 the length of that whole median. What was the whole median called again? From the vertex to the side. BF, okay. So the length of PF is 1/3 the length of the whole thing. Okay, we'll put some numbers to that in just a minute. Then the segment BP is 2 times the length of segment PF. Okay, does everybody see BP from the vertex to the centroid? That is twice the length of that smaller part. So far, so good? All right. Yep. You said something? Okay, and then the next one is BP is 2/3 the length of the whole median, which is BF. Okay, you don't have to memorize all these fractions and stuff. I'll tell you the easier way to figure it out once we get through this, okay? And then PF again is going to be 1/2 of BP. Okay, so there's a lot of relationships here. So let me give you a for example just with this one I have drawn on the board. Let's say that's my centroid. Is everybody paying attention? Up here on the board. If I told you that this whole segment, let's call it BF because that's what we're dealing with. If I said BF equals 9, okay, and I wanted to find the length of these 2 smaller segments. Okay. The one from the centroid to the side is 1/3 of that. What is 1/3 of 9? 3, right? So that would be 3. What would that have to be in order for the whole thing to be 9? 6. Okay, so basically what all of these say is that PF is 1/3 of the whole thing. So I take the thing and divide it by 3. Then it says that BP, this top one, is twice the smaller one, right? Okay. Then it says that BP, this one, is 2/3 of the whole thing. That's probably the hardest one to figure out, but I'll tell you other ways you can do it. And then PF is 1/2 of BP. So when you have a median, whatever the whole thing is, the bottom part going from the centroid to the side is 1/3 of it, and then you take that and you double it to get the top part. That's really all you have to think about. This bottom one is 1/3 of whatever the whole thing is. This one is twice that. Does that kind of make a little bit more sense than all the fractions? Yeah? Okay. So we're going to start with this first picture. Let's label everything it tells me in my picture. It says P is the centroid of triangle JKL. Label JK. What does it tell you the length of JK is? Put that in your picture. 22. JK is the entire side of that triangle. That's 22. What's the next thing it tells me? KN is 13. And then it tells me OL is 18. All right, before I start answering my questions, I want to go through and fill out what I can fill out based off of the information. If I am told that P is a centroid, that means all of my segments are what? Medians, which means those letters M, N, and O are all what's at the sides. Look back at your definition of median. It hits where? At the midpoint, right? Okay, so let's use that. If this whole segment is 22, what would each of the smaller ones be if M is in the middle? Okay, so that would be 11 and that would be 11. Now looking at KN, if KN is 13, what else would be 13? NL, which would make that whole side how much? 26, okay. And if OL is 18, what else is 18? JO, which means the whole thing would be 36. And that is all they gave me, so that's all I can fill out. What I want you to do is go through and answer any question, all of those questions if you can. Answer whichever ones you can. Tell me what the length of KM is. Tell me what the length of NL is. KL, JO, and JL. Okay. Knowing that P is the centroid lets me know that all of those segments, Segment KO, segment JN, and segment LM are medians, which means M, N, and O are the midpoints of the sides. That's why it's important for you to know which ones go with what here. What's KM? 11. Okay. What's NL? 13. What's KL? JO?
18.
And JL? 36. So we were able to answer all those questions? Everybody okay with that? All right. Now, we're going to do the same thing to this next picture. We're going to label what it tells us, fill in what we can, and then answer our questions. This one is going to be a little bit more involved because it's giving me lengths of my medians now. It tells me Z is the centroid, so that means W, X, and Y are the midpoints of my sides. What's the first piece it tells me? What is TZ is 60. Okay, so let's look at this. That goes from my vertex to the centroid, so that is the bigger part. What is the smaller part of that segment, that median? From T to Z, the other piece would be from Z to Y. Okay. So remember what I told you, this top part is twice what that bottom part is. So if the top part is 60, what would that bottom part be? What's half of 60?
30.
30. So from Z to Y would be 30. It's half of that 60. Okay, from the vertex to the centroid is twice what it is from the centroid to the side.
How do you mean 30?
It's half of 60. Does that make sense? Somewhat? Okay, you got to remember those. From the vertex to the centroid. This piece here is the bigger piece. This is the little piece. Okay? And the little is always half of the big. What's the next thing it tells me? XZ is 28. I need to make the picture bigger. I can't see. Okay, here's my question. Is XZ the smaller part of my median or the bigger part? It's the smaller. So in order to find the bigger part, the ZV, what do I do to 28? I just multiply it by 2. So what would that be? 56? Okay. If you're given the little part, you double it to get the big part. If you're given the big part, you cut it in half to get the little part. Make a little bit of sense? Okay. All right, what's the next thing it tells me? All right, where's WZ? Okay, WZ is here. So that is 25. Is that the little piece or the big piece? The little piece. So what would the top part be? 50. All right, now go through and answer your questions. There's a lot of you that are not paying any kind of attention. Just remember, you have a quiz next week. It's the last one of the 9 weeks. It can hurt your grade. I would strongly recommend you try this. Those of you that are paying attention, thank you. What would ZV be? What did we label it as? What about ZY? We labeled that as 30. ZU? 50. Ooh, what about TY? What would that be? 90. I would add the 60 and the 30 together. And then what about XV? 84? Yeah, add 28 and 56 together. Okay, so that's the thing with a centroid. If you're given the whole piece, you divide it by 3 for the little, and then you double it for the big. okay? If you're given the little, you just double it for the big. If you're given the big, you cut it in half for the little. Is everybody okay with that? All right, let's flip it over. The next segment we are going to talk about is the altitude. Okay, think about altitude of a plane. That talks about how high it is, right? We talk about when we measure how high we are, how tall we are. How do we stand? Straight up and down, which means we make what kind of angle with the ground? Right, okay. So an altitude is a segment that joins a vertex to the opposite side so that it is perpendicular to that side. And so again, the altitude is going to come from a vertex, and it's going to go straight down, and it's going to be marked perpendicular. This is where I need you to understand the difference between the only two that have perpendicular in them. Perpendicular bisectors and altitudes. Okay, everybody look at the board. Perpendicular bisectors do not have to come from a vertex. They are just straight perpendicular, cutting that bottom part in half. Okay? Whereas the altitude has to come from a vertex. That's the difference between the two. On the quiz next week, I'm going to give you pictures like this with markings, and I'm going to ask you, are these perpendicular bisectors, are they medians, or are they altitudes or angle bisectors, okay? So you need to know the difference in the markings. Perpendicular bisector does not come from a vertex, whereas altitude does, okay? Don't get those two confused. Also, perpendicular bisector would have this segment marked congruent, altitude would not. Is everybody okay with that? Now, what I just want to show you is the altitudes can actually be in three positions depending on what kind of triangles we have. What are the three types of triangles according to our angles? Acute, obtuse, and right. Okay. So looking at that first picture, what kind of triangle does that look like? Acute. Okay. So this one looks like an acute triangle. And so my altitude is actually going to be inside the triangle. Okay, it says it can be inside. What kind of triangle does that second one look like? Obtuse. Now, if I were to draw my altitude from this top vertex, it would have to go straight down. And so the altitude on this one is actually outside of my triangle. Okay, you can kind of remember that, obtuse, outside. They both start with an O. And then what kind of triangle is this third one?
Right.
A right. Okay. And with a right triangle, my altitude coming from that top vertex is actually on the triangle. It's just part of the side. Okay, so if it's an acute, your altitude is going to be inside. If it is obtuse, your altitude could be outside. And if it is a right triangle, it could be on. Okay, so those are just the three different positions. Not that you really have to know anything about that. It doesn't lead you to anything else. I just need you to understand that sometimes the altitude can be inside, sometimes it's outside, and sometimes it's actually just part of the triangle. Everybody good with that? All right, the next one, the altitude has a point of concurrency called the orthocenter. Okay. And the three altitudes, can't spell. Altitudes of a triangle intersect in a point called the orthocenter. On your quiz, you will also have to be able to tell me. I will say, what is the point of concurrency for your perpendicular bisectors? You'll have to know that that is circumcenter. I'll say, what is the point of concurrency for your angle bisectors? You have to know that that's the incenter. I'm going to say, what's the point of concurrency for medians? That is centroid. And what is the point of concurrency for altitude? That is orthocenter. Okay, you have to know those and which ones go together. So what I want you to do first is list the altitudes. Tell me what three segments, what are the name of the three segments in that picture that are the altitudes? Okay, just like we did the medians in the other picture. Name the altitudes. They have to come from a vertex perpendicular to the opposite side. So we should be filling in that first, second to the last question. What are my altitudes? What segments? Give me one of them. Okay, it's got to go from the vertex to the other side. Y'all are giving me like parts of the altitudes. You're giving it to the orthocenter.
E.
Which one?
E.
E. That's one of them. That's one letter. Where does it go to?
E going to C.
Through the triangle.
A.
AE, yeah. Okay, so AE would be one altitude. Okay, from the vertex to the side.
DC.
What'd you say, DC? Mm-hmm. DC or CD, either way you want to call that one. That's from the vertex. Whoops, I'm trying to write. From the vertex. Come on. From the vertex to the opposite side, that one. And then what's the other one? BF, yeah. Okay, so that's the third one. From the vertex to the opposite side. And then the orthocenter, I've colored all over mine, but what is the point where all three of those meet? P. The orthocenter doesn't have, and you know how like the circumcenter, we said it was equidistant to the vertices. The incenter was equidistant to the side. The centroid had its fractional relationships. The orthocenter doesn't have any relationships, so there is not going to be anything that you have to find involving that ortho.